All right, 1.4, we're going to talk about betweenness and midpoints. So a lot of what we do in this section will kind of play off of what we did earlier with segment addition and congruent segments and midpoints. So there isn't too much new stuff. We're just kind of showing it in a new way here. All right, so all betweenness says is that point R is between points P and Q if and only if the points are collinear, which we talked about, right? That means they're on the same line, and that PR plus RQ equals PQ. So there's that segment addition that we're talking about, right? So again, all we're formally saying here is that point R is between points P and Q if they're on the same line, and if I take PR plus RQ, and that equals PQ. So that's that small plus small equals big that we talked about in class. All right, so first example here, we have points K, L, and J are collinear. If KL is 31, JL is 16, and JK is 47, which point is in between the others? All right, so we have a number line, and we have points K, L, and J. All right, well, how do we figure this out? Well, in the previous slide, right, we said small plus small has to equal the big, right? So let's look at, we have KL is 31, we have JL is 16, and JK is 47. So if I go back to this small plus small has to equal big, right? This has to be a small and this has to be a small because this number is the biggest one, right? So what's that tell us? Well, that means JK has to be the largest distance. So that would be 47, right? And then KL is 31. So this would be 31, which makes this 16. Okay, so which point is between the others? Our answer would be point L. Okay, and again, we looked at that small plus small has to equal big. We looked at the three distances given to us, and we determined which of the three is the biggest. That was JK, so we know those have to be the two outer points, and that L has to be somewhere in the middle. All right, here's another one. We're just given some data here. So FG is 12. I'm going to label that. So FG here is 12. FJ is 47. So that's from here to here, right? That is 47. And I want to figure out what is GJ. So what is this part right here? Okay, so this is identical to segment addition that we did in 1.2, right? We're taking the small plus the other small has to equal the big. So FG plus GJ has to equal FJ, right? And we talked about doing this algebraically. So if FG is 12, JG is unknown, which that means that's a variable, and FG is 47. We're just going to subtract that 12 to figure out what's missing. So then GJ would be 35. All right, and lastly, we're going to look at a situation where, again, we're just given values. So it's saying that RS is 7y minus 3, or sorry, plus 3. So I labeled that. It's telling me ST, which is this piece, is 2y plus 8. And then RT, which is, again, this whole thing, is 65. So S is between R and T, given the picture. And again, this is just segment addition, so small plus small has to equal to big. So 7y plus 3 plus 2y plus 8 has to equal the whole thing, which is 65. Okay, so algebra review here, make sure we can combine our like terms, 7y and 2y, they're on the same side, so we add them together. So that's 9y. And I have a 3 and an 8, same thing, same side, so I can add them together. Okay, so I combined my like terms. Now I just have 9y plus 11 equals 65. Subtract 11 from both sides. 9y equals 54. Divide by 9. So y equals 6. Again, we saw this a lot in 1.2 when we did this. If y is 6, that's not my final answer, right? Here, it's asking me for rs and st. So we have to make sure that we go and we plug this back in. So rs is 7 times 6 plus 3. So 7 times 6 is 42, plus 3 would be 45. And then st is 2 times 6 plus 8. So 2 times 6 is 12, plus 8 is 20. And then again, it's always just good to double check, do 45 and 20 equal 65, which is the whole thing? And yes, they do. Okay, so that's 1.4. Like I said, pretty similar to segment addition stuff we looked at in 1.2, but just kind of a little bit different way of looking at it or presenting information.